10 video explainers. So in this problem, there's a 1 kilogram physics book that's connected by a string to a 500-gram coffee cup, and the book is given a push up the slope and then released with a speed of 3 meters per second. And there are two given coefficients of friction, one for the static friction and one for the kinetic. So right now we're trying to find how far does the book slide. So to get that total displacement, I figured that it would be best to get the acceleration of the book as it's going down the slope. So in order to do that, I figured that since force is equal to mass times acceleration, I could take a summation of all the forces and eventually get the acceleration of the system. So the forces that are acting on this book here are the tension, friction force, and the gravity force. And I drew a kind of diagram over there, and there could be, so the coffee cup that's pulling it would be essentially just under where it says Fg. All the equations here for the tension, the gravity force, and the friction I have over here. In order to go through this relatively quickly, you can see here that for the friction and the gravity, both of them just return a force in newtons. However, the tension is slightly complicated because due to the fact that it's a system, the way I looked at it is that the force is going to equal to the total force of that system is the downward force minus just the acceleration. So that downward force being the gravitational, and then to get the acceleration one, it's just the mass of the cup times the acceleration of the system. So if you pull out the mass of the cup, you get over here the force of the tension is equal to mass of the cup times gravity minus acceleration of the system. So now we have a variable for the acceleration of the system that we're trying to find. So it was 1.84 for the newtons for the friction force, 3.35 newtons for the gravitational force, and 4.9 minus 0.5 times the acceleration of the system. And that just comes from multiplying 0.5 kilograms out to 9g minus a system. So gravitational acceleration being 9.8 meters per second squared. So after doing some quick math, you get that, so you add the variable now, the acceleration of the system, you add that over, and you ultimately get that the acceleration of the system is equal to 6.73 meters per second squared. So just some conditions that were established is that we're assuming that the final velocity is going to be 0, because that's when the book's going to stop. So just use this kinematic equation, final velocity squared minus initial velocity squared times 1/2 the acceleration is going to equal the displacement. And we know that initial velocity of the book is 3 meters per second. So we plug everything into that kinematic equation, and we get 0.6686 meters for the total distance the book would travel. So now, trying to figure out whether or not the book would stick to the slope or whether it slides back. So we know that the determining factor is the true relationship of the forces being gravity and friction. So if the force of gravity is going to be greater than the friction force, then the book's gonna slide. So just from previously, we know that the force of gravity was 8.25 newtons, and the friction force is 4.6 newtons. And being that the force of friction is less than the force of gravity, I realize I made a slight typo there. That should say F gravity, not F friction. But being that the force of gravity is greater, then it's going to slide. So, yep. Also, something I forgot to mention is how it relates back to some of the material in class and some of the tricky parts. So some of the tricky parts is just finding out the best way to approach this problem. I think that once you recognize what force is and what variables you know and don't know, then it becomes a lot more clear on how to solve the problem. And just how this relates back to class is just the interaction of two objects, and and just, different action reaction pairs of forces, and also just how you getting variables from one, like an acceleration, for example, and tying that back into a kinematic equation. So yeah.